Hey everybody.
Meaning the one person that watches my videos.
I know it's been a while since we last spoke. I've just been busy with really important things. First off, if you're only here for the tutorial, the whole purpose of this video, then you can just skip to this time right here, right now. I'm just going to talk about some life stuff and what I've been up to since I last uploaded, because it's been a while. So without further ado, I've been making a game! It's pretty okay. The working title for it right now is 15 Minutes to Jupiter. I have a lot of ideas for story elements and other things like that I'm not going to reveal, but it's going to be a fast-paced 2D bullet hell roguelike platformer. I know that's a lot of action words I just threw at you, but we're just gonna gloss over that and kind of move right along into just showing you what I've built so far, because it's been about 2.5 months of dedicated work on the project. But it's not quite at the level where I can call it any of those words I just called it, but it is a solid foundation that I can build off of, I think. So I just want to kind of make a log of what I've been doing and show off a little, if I can say that, because I can't, because it's not show-offable. Anyways, let's get right into it. The first thing the player gets greeted by is this menu system. There are animations for the buttons and the background, as well as the menu music that I composed a while ago, which you can actually hear now. Most assets you see here are placeholders, as you may be able to tell, and will be updated multiple times before this concept demo releases. Actually getting into the game, I've created a basic working pause menu, which will eventually have the option for a settings window as well. That's what I decided to show off first out of everything? Okay. We've also got a timer user interface, which will give the player a game over after reaching 0, and the health and stamina UI you can see here, which is the whole point of this video today. The player can attack enemies in a 360-degree arc, they can move their player left and right, they can jump and climb walls, they can sprint left and right, they can dash in the air, they can lock onto enemies with their cursor, and they can be attacked by enemies as well. There are also a couple of other base level systems implemented, like a wall jump and a smash attack that I didn't show here, but the point is these are all base level systems that pretty much any game like this has nowadays. I have a lot of plans moving forward for new moves I still want to implement, as well as how to tie all these moves together to create a cohesive system where the player can smoothly transition between and combo together the different mechanics that they're given. But that's basically where this project is at now. I know, real impressive for 2 months worth of work, right? I'll continue to post updates like this as the project progresses, but I was finally content enough with this launchpad that I've built up in order to share what I've actually been doing. With that all out of the way, let's get into the tutorial of this video. So, first things first. When setting up a health system, you need different health sprites to switch between. My health sprite sheet has an empty, half full, and full heart sprite. Next, we gotta do some magic in the inspector to make things look right. First, set pixels per unit to the pixel width of one of your sprite sheet images. Set the filter mode to point, no filter, and compression to none. Then apply these changes and head on into the sprite editor. Go to the slice menu and change the type from automatic to grid by cell size, and then set the pixel size to the width and height of one of your sprite sheet images. Click slice, then apply your changes. Set each of the new slices pivot unit mode to pixels. Now go to the hierarchy where you should add a UI image object and call it Heart Manager. Under the canvas that spawned in, go to the inspector and change the canvas render mode to screen space camera. Go back to your hierarchy and drag your main camera into the render camera slot under the canvas. This step definitely isn't necessary, but it makes it easier to visualize your canvas spacing. Finally, go under the Heart Manager image object we made and add a child image object from the UI menu. We'll call this object Health Crystal. With the basics in place, we need to set up our heart object. Select the Health Crystal, go to the inspector, and add a sprite renderer component to begin. Next, create a script called UI state. I'll be calling mine demo UI state for the sake of this video. Open the script and create a sprite variable for each of your health sprite images. You should serialize this field so that we can set these objects in the inspector. Create a sprite renderer variable so we can control which image is shown, and on awake, we should get that component from our heart object. After that, we want to create a method called setHeartImage. In the method arguments, we will call for an enum named UIHeartStatus, which I have named demo UIHeartStatus, and we will also add the variable name for this enum argument. In our method, we want to create a switch statement that uses our enum in order to change between our different sprite images. The final step for this script is to set up setEnum, giving it the same name, UIHeartStatus. In the enum, we will have three states: empty, half, and full. Now, go back to the editor and add the script onto your heart object. Also add your differently filled heart sprites accordingly in the inspector options. As an editor's note, if you added a reference image into your sprite renderer, do not worry about not being able to see your sprite at this point. I will solve this issue later. If you do want to see your reference image, just scale up the heart image in the transform settings. Moving on, let's set up our player health next to get some interaction in our scene, so that this doesn't happen. Go to the project window and create a script called, you guessed it, player health. Mine will of course be called demo player health. After you open the script and take out the trash, we can start creating our variables. First, we need to get the player's collider to detect when they collide with an enemy. After that, we need to get the game object of the player to later destroy it if our health gets too low. Next, we want to add different floats so that we can check the player's current and maximum health. Let's create our onCollisionEnter2D method now to handle our collisions. Reminder, this is just for collidable objects, not for triggers. Use onTriggerEnter2D for that case. In our method, we want to check if the object we collided with has a tag of enemy, and if it does, then we want to collect the name of that object. Create a local float for the damage we will apply and initialize it. Now, we want to check if our enemy has a specific name. That way we can reuse this class for multiple different types of enemies in order to set varying damage amounts. Lastly, call a method we are about to build with the name takeDamage. Start by adding a float argument for the amount we want to damage the player by, then subtract that amount from the player's current health. Add this event variable that we will use to switch our sprite images, and in the takeDamage method, invoke it. Check now if our player health is less than the minimum amount, and if so, destroy the player object. You can also just set this field to lowercase game object and have it do the same thing, as long as the script is on the player where it should be. Last step for player health, go back to the player object in the inspector, add your script to it, drag in the collider and the player game object, and then set your max health to a number divisible by 2 and your regular health to whatever you want. Another editor's note here, because I apparently can't record worth a damn. As a game standard, your player will have the tag player and your enemies should have their own unique tag as well. But this is especially important in our case here because we specifically check for the tag enemy in our collision script, so make sure you set those on the corresponding objects, otherwise our scripts won't work. On to the final task we need to complete in this project. We have to set up our heart manager. I realize I didn't show this in the beginning, but you should drag the transform of the heart manager to wherever you want your hearts to start spawning on the canvas. For me, that was the top left. As before, we created a similarly named script for our object, heart manager. We opened it up and got rid of the trash. We'll start by adding a variable to get the heart crystal object that we made. Then we want to gather our player health script and 2 floats to customize the X and Y spacing of our different rows of hearts. Finally, we want to create a private list of our UI state script in order to change the images of each of the hearts that we spawn in. Now, on enable, we want to gather the total number of hearts we need to make and draw them to the screen. Likewise, on disable, we want to delete those same hearts from that screen. On start, we'll call our draw hearts method, and then we will build that method. In this method, we want to start by ensuring there are no existing hearts in the scene, so let's call another method that we haven't built yet. Now, since we divide each heart into 2 halves, we want to get our max health remainder so that we can spawn the correct number of hearts even if we have an odd valued max health number. We are going to actually calculate the hearts we need to make by using that remainder and by dividing our max health by 2 for the reasons I just said 1 second ago. With that calculation, we can go ahead and set up a for loop that will spawn our hearts the correct number of times. After that, create another for loop, but this time we want to iterate through the hearts list variable that we made. If you want a more in-depth explanation of how this calculation works, I can give it in the comments, but what we're doing is getting the status we should set for each of the hearts that we spawned in, full, half, or empty, 2, 1, or 0 correspondingly, based on the remainder of what the value that we calculate here is. Pause. That was a terrible explanation. What we're doing here is getting the current player health, which we'll say is 5 out of a maximum 6 health currently. If we have 6 max health, our script would spawn in 3 hearts. This would mean hearts.count has 3 entries. What this calculation does is for each heart in the list, we get the remainder of the player health in order to judge if that heart should be full, half, or empty. For example, if our player health is 5 and we are on the first heart, so the 0th index, then our equation would look like this. Since the upper limit of our equation is 2, the clamp function will return 2 as our remainder instead of 5, and resultingly set that heart to full. The next time this loop ran, the result would return 3, which gets clamped to 2, setting the heart to full again, and then in the final loop, the result would be 1, or a half heart, which would be returned as is because that is within our range. With that out of the way, let's keep going. We need to create the method that will actually spawn one of our heart game objects in. The first thing we'll do here is spawn a clone of our heart prefab, just as I said. Then we make that object a child of our heart manager parent in our scene, just as we currently have things set up in the hierarchy. After that, we need to gather what heart we are currently on so we can differentiate between our 2 rows. And if this is the first heart we've spawned in, then we're just going to set it to the center of our parent transform. Otherwise, if this is not the first heart we spawned in, then we'll want to get the transform position of the last heart that we did spawn in. After that, we'll create a local variable called position, and if the index we are on is an odd number, we will want to set the position of that heart to the same Y as the first heart that we spawned in, but further along on the X-axis. Meanwhile, if the index we are on is an even number, we will want to set the Y position of the heart lower than that of the first heart we spawned in so we can create that honeycombed row look. The way we can handle this so you're able to personalize your own UI to whatever you like is by using those X and Y spacing variables that we made earlier instead of spawning these sprites in a hard-coded pattern. Now we can set our newly spawned in heart to that calculated position, and by scaling up the object, we should also be able to see the sprite now. To finish this method, we'll set the sprite to an empty heart and add the object to our list. Last thing we need to do in this class is to create the clear hearts method, and this will simply destroy all the child transforms under our game object and then reinitialize our list to a blank state. Now, we're going to go back to our hierarchy, turn our health crystal into a prefab, and delete that shit. Then we'll drag our script onto our heart manager, and in the inspector we'll add the heart prefab, drag the player game object into the player health script slot, and set our X and Y spacing to whatever we want. If I haven't screwed you up with all my goofy naming conventions by now, then congratulations, you should have a working health UI. That concludes everything I wanted to cover in this video. If you guys are interested at all in how I designed any of the systems in my game, you can either comment down below or go and check out my GitHub. This game is literally a public repository that you can just download and open directly through Unity, and I'm constantly committing new things to it. Besides that, I just wanted to say thank you guys for watching, and catch you next time.